All right, so for AVL trees, one important thing you need to know that this height, like depth, will always be all log of n. That's a pro. The other thing is, mainly the thing with AVL trees is you have to calculate the balance factor. And balance factor is the height of the left subtree minus the height of the right subtree, right? And then you make sure that it stays balanced by making sure that the difference is no more than 1. So your accepted balance factor values are -1, 0, and 1. And you ensure this by doing a series of rotations, right? So we'll see what happens now. So we want to insert 1, 2, 3, 4, 5, 6, right? Okay, so you have 1.
Okay, I found this on the web. For accept the balance factor values are -10.
Okay. 2. And you have 3, right? Let's calculate the balance factor. The balance factor is any leaf is 0. This one is left minus right. Left you have nothing. Right you have 1. Do not mean to undo that. So this is going to be -1. That's still fine because it's still in the set. This one is going to be -2. Since it's -2, that's not acceptable. So now we see it's right heavy, right? So we rotate it once to the left. So now we have 1, 2, and 3. Now, balance factor of this is 0, and this is 0. So this is good. Let's continue inserting. Next thing we want to insert is 4, right? So you have 1, 2, 3, and then 4 goes here. Let's calculate the balance factor. This is 0. That's going to be -1. That's going to be 1 minus 2 is -1. That's going to be 0. This is still good. Let's insert 5. 1, 2, 3, 4, 5. As you can probably guess, the balance factor is not okay now, right? This is going to be 0. That's going to be -1. This is going to be -2, right? Because there's no left subtree, there's just right subtree. Now we stop worrying about the balance factor of these. We always start calculating BF from the bottom up, right? So now since we stopped at this is not an accepted value in the set, we have to rotate that. And in doing so, you're going to realize that you don't have to worry about the balance factor of this one because it's going to even out. So we still see it's right heavy, right? So we have to rotate it to the left, a single rotation. So you have that. Now your new parent is going to be 4. It's going to be 3. That's going to be 5. So balance factor is 0, 0, 0. 1 minus 2 is -1. That's 0. You see, we didn't have to rotate 2 because we rotated from the bottom up. Lastly, we want to insert 6. So you have 2, 1, 4, 3, 5, and then 6, right? That's very squishy. So the balance factor of this is 0. This is -1. That's 0. The balance factor of 4 is 1 minus 2 is -1. Balance factor of 2 is 1 minus 3 is -2. That's going to be 0. So now 2 is out of place, right? So to balance that, it's negative, so it's right heavy. We have to rotate left, right? So to rotate left, you might be thinking, okay, how do you rotate left? If 4 is the new parent and 2 is a parent of 4, what happens to the 3, right? So for that, let's just ignore this 3. We're going to kick out the child. We're going to bring 2 down as a parent of 4. Let's erase all the balance factors because these are outdated now. Right? So now, this 3, we're just going to take this 3 and place it as a child of 2. So the rule is whenever the children get in the way, you kick them out of the home. All right? All right, cool. Now this is proper AVL. 4 is balanced, 2 is balanced, 5 is -1, everything else is 0. All right, next up, let's delete 3. What happens when you delete 3? An AVL tree is always balanced based on the balance factor, right? So if we delete 3, that doesn't change it. That does not make it unbalanced, so that's fine. Insert 2 into 1, 3. This is the example I came up with if like we didn't get to talk about a double rotation, like we just did single rotations, right? So if we want to insert 2 into 3, 2 is going to go here, right? 2 is going to have a balance factor of 0. 3 is going to have a balance factor of 1. And then 1 is going to have a balance factor of negative 2. Now, for this, if you want to, if you see the negative 2 on 1 and you think, okay, it's right heavy, you want to just rotate left, then if you rotate left, it's going to be like this. But is 1 less than 3? It's not, right? So in this case, you want to do a double rotation. To do a double rotation, first you rotate right on the downward node. So that's going to be this. So this is going to be 0. This is going to be left minus right minus 1. This is still going to be minus 2. Now, if you do a single rotation to the left, you're going to get 2, 1, 3. And is 2 less than 2? 1 is less than 2? Yeah. Is 3 greater than 2? Yeah, it is. So this is a double rotation. All you need to know is that you keep calculating the balance factor. You make sure it's within this. If it's not within this, you either do multiple single rotations or you do a double rotation. And that's it.